We're starting out with a new product design. We're really not sure if the components we're choosing are robust enough for the field conditions we're expecting our product to function within. There's a set of tests that can help with that. Listen in for more about environmental stress testing. Hello and welcome to Quality During Design, the place to use quality thinking to create products others love for less. My name is DIANNA. I'm a senior-level quality professional and engineer with over 20 years of experience in manufacturing and design. Listen in and then join the conversation at qualityduringdesign.com. There is a rather large family of test methods associated with Qualitative Accelerated Tests, also known as RETs or Reliability Enhancement Tests. But today we're focused on the models that are used to help us with design. There are industry-accepted test models that can be used in the early phases of design process. Knowing about them will help us with future test plans and project management. Today, we'll talk about environmental stress testing, and we'll remind ourselves a little about HALT. Qualitative accelerated tests are evaluating the robustness of our product. It shows us what the principal failure modes will be under common use conditions. It gives us an opportunity to change our design or how we make it to make it more robust and reliable. The failure modes we find can be from the design itself, manufacturing production, or other handling situations. Handling could be things like temperature, humidity, or vibration extremes that can be part of shipping and handling of the product. We get qualitative information that helps us understand the weaknesses of our product. We do not get numerical data that we can use to mathematically model our product's failures, so we cannot calculate predictions about the life of our product. To get that data, we can use a different type of test, such as reliability life test or quantitative test. We're not going to talk further about those today, but I will let you know what other Quality During Design episodes covered reliability life testing. The ultimate goal of a qualitative accelerated test is to identify failures in our product. We study the root causes of those failures to ensure that it's the type of failure that is something we'd see in the normal use of our product, and then we work to eliminate those root causes. The qualitative testing can be performed in a matter of hours or a few days. To perform qualitative accelerated testing, we expose our parts to stresses that are higher than what our product would see in the field. We can do this by exposing the products to many more use cycles that the product is originally designed to be able to do, like pushing a button every 2 minutes for a test, which is accelerated from its normal use case of 1 push per week. Or we expose the products to higher stresses than would normally be seen, like an extreme temperature, humidity, electrical loads, vibration, and so on. We then study the failure modes of our products, determine the root causes, and, this is important, check that the causes and failures are something that we'd see in the field under normal use conditions. For example, we performed testing and our failure was a component snap. When we looked into why that component snapped, we find out that it's because it was rubbing against a feature of our tool that we're using to clamp the product into the vibration machine. That's not a failure that we'd normally see in the field. We may decide to correct the fixturing and perform the test again. For qualitative accelerated testing, we normally take a stepwise approach. We want a robust design before we start refining the manufacturing process. We first focus on fixing the failures of the design itself. After the design is optimized, we can perform some additional accelerated tests at slightly lower stress levels to identify defects caused by manufacturing. And then, if we're inclined, we can use a stress screen or stress audit as part of our manufacturing process as a type of inspection or quality monitoring of our products. EST, or Environmental Stress Test, is a qualitative accelerated test. We may also call it an overstress test. We would want to use these tests very early in the design process to shortcut the development of our designs. Strong components will improve the reliability of our product. Overstress testing is usually performed by testing just a few components. It starts with a stress profile that's just below the operating spec of the design. Then we increase the stress continuously until we get a break. We then perform our root cause analysis, ensure the failure would be something that can be seen in use, and then work to make the component more robust against that failure. Then we test it again. HALT, or Highly Accelerated Life Test, is also a type of qualitative accelerated testing. Like environmental stress test, it too is used during the design phase to create failures using high stress profiles. The difference is that we're usually using HALT to test systems and their interfaces, and then use that information to change the design. Another difference is how much we're accelerating our stresses. In HALT, we're highly accelerating our failures using stresses to the extreme, which is why we use it for design improvement and not necessarily for manufacturing improvements. Contrary to its name, it is not a reliability life test. We cannot use the results of HALT to evaluate the life characteristic of our product, to predict the reliability of our product in its use environment. If we want data like that, we need to consider quantitative reliability life testing, and we discussed this in a previous Quality During Design episode. Choosing the stress levels to apply and how to accelerate them can be a challenge to figure out, especially if the stresses interact with each other. A high level in one stress may positively affect the level of another stress. For example, the results of our high vibration and high humidity environmental stress testing may indicate that our design is robust against wear failures in high vibration and humidity. But a high humidity stress level may decrease the rate of a wear failure mode. Our wear results are more robust than would be seen in normal use cases because our high humidity helped prevent the wear mechanism. To address this, we take care to evaluate the failure mode and its cause, and think about the physics of failure of that mode of breakage. What's today's insight to action? There are ways to make our designs more robust through qualitative accelerated tests. We can test components and systems at higher stresses to highlight where our designs are weak, then redesign them to be more robust. We make sure we've already clearly defined the operating and use environment of our product. If not, we'll go back and do that. If we're in the early stages of product design, consider using qualitative accelerated tests to help you make a more robust design. Contact a reliability engineer to get help and get started. There are previous Quality During Design episodes that you might find useful. Episode 6, HALT, Watch Out for That Weakest Link, discusses highly accelerated life testing. Episode 36, When to Use DOE, Design of Experiments, gets into how to use this test process to identify the stresses that affect your design. Episode 37, Results-Driven Decisions Faster, Accelerated Stress Testing as a Reliability Life Test, gets into that quantitative reliability testing that we can use to make predictions. Please go to my website at qualityduringdesign.com. You can visit me there, and it also has a catalog of resources, including all the podcasts and their transcripts. Use the subscribe forms to join the weekly newsletter where I share more insights and links. In your podcast app, make sure you subscribe or follow Quality During Design to get all the episodes and get notified when new ones are posted. This has been a production of DIANNA Enterprises. Thanks for listening.